All right, so we've got our last example video here for 5.2. So if you notice, we've increased our difficulty here because now we're doing a combination of adding and subtracting. So we can extend that idea of adding and subtracting two rational expressions, as far as we need to. But if you notice, we would really like for all three of these denominators to be the same, because that would make our job, fairly quick, fairly efficient, but they're not. So unfortunately for us, that means that we are going to have to make them match before we can actually do any of the adding and the subtracting that the problem is actually referring to. So my hope is, again, just like from that previous example, that you're looking at this denominator and you're already thinking, I know how to factor that. And so that's probably where I would start with this one. So I'm just going to copy the ones I don't have to worry about, because again, that v plus 5, it's not going to factor any, it's not going to get any more simplified than a v plus 5 than that, but the second one will definitely look a little different. So v squared minus 25 is a difference of two squares. So there's a v plus 5 and a v minus 5 factor involved in the factored form of v squared minus 25. And then again, nothing that can be done to that v minus 5 denominator in terms of factoring there. Okay, so definitely still different. Just because we factored didn't mean that we made those denominators the same, but hopefully you're starting to recognize a little bit about what we can do in terms of that factoring revealed some underlying structure that's pretty interesting. So again, the name of the game is, when we're adding and subtracting rational expressions with unlike denominators, is we have to make them match. So I can't make v plus 5 look like v minus 5. Because again, the way that we change denominators is by multiplying. So you might think, oh, if I multiply by -1, well, if you multiply by -1, it does change the plus sign here, but it actually would kick out a negative in front of the v, which that one does not have. So I can't change this one into this one or this one into this one, but this denominator is pretty interesting. It is a product of the v plus 5 denominator and the v minus 5 denominator. So this denominator actually right here is what we would refer to as our LCD. So sometimes that LCD is already staring you in the face in that problem. Just to make that a little bit more clear, that LCD. So I've got that v plus 5 denominator, and again we talked about, that's just, we consider that its own factor. Now the v plus 5, let me write that as that original v squared minus 25 denominator. We already saw that that factored as v plus 5, v minus 5, and then we had our v minus 5 denominator, and that would simply be its own factor. So to form that LCD, right, we see this has a factor of v plus 5, so it occurs at most one time in any, doesn't occur any times here, but it occurs one time here and one time here. So the most that factor occurs is one time. So my least common denominator needs to have one factor of v plus 5 in it. And then we see a factor of v minus 5, and it's repeated in our third denominator. Not up here, but it's not a big deal that it's not up there. It's just if it occurs any time in the factored form, it needs to be included in our least common multiple. So it occurs here and here, but both times it occurs once in the factored form, so we just record one factor of that. So there's your LCD, and you notice we already have that here. So sometimes that LCD is already staring at you in the face, and you can maybe not necessarily have to go through this step, writing it all out. You can actually just notice it, recognize it, and say, okay, that's the denominator that I want to make everything match. So what do I need to do? So this denominator already has a v plus 5 factor. So it's just missing the v minus 5 factor. So I'm going to give it a factor of v minus 5 by multiplying by v minus 5. And then I also need to multiply that numerator by v minus 5. So remember, v minus 5 over v minus 5, that has a value of 1. So we could actually, cross out that common factor if we wanted to and returned to our 3 over v plus 5. Okay, this one is already good. I don't have to make any changes to it. We've already decided this is the denominator we want everything to match to. So we just get to skip over that one, and we're going to go to the v minus 5 denominator. So all this denominator is missing is the v plus 5 factor. So I'm going to give it a factor of v plus 5. I'm multiplying by v plus 5, and then I will also need to do that in the numerator as well. Okay, so got our LCD. Now all of these have the same denominator. So I'm going to go ahead and just kind of clean it up a little bit. So that's going to be 3v minus 15. And then I'm going to leave this v minus 5, v plus 5, plus that middle rational expression did not change at all. And then our last rational expression, its equivalent form is 2v plus 10 over v minus 5 times v plus 5. And again, I know that the ordering of these factors is not necessarily all the same throughout the denominators, but multiplication is commutative, so they express the exact same thing. So we have our denominators matching now. So I get to just make that the denominator on my rational expression. And then I'm going to take all of these numerators and join them with the appropriate symbol. So it's going to be 3v minus 15, I'll put that in parentheses, plus v plus 6 minus 2v plus 10. And so that's going to simplify to be 2v. I got 3v, a v, and a minus 2v. And then I've got negative 15 plus 6, and then a minus 10. Again, if you need to, you can change this to a plus, and then you go in here and you change the signs of all those terms. So that would be a negative 2v minus 10. So negative 15 plus 6 minus 10 is going to be a negative 19. And then I'm going to go ahead and change that denominator back to its simplified form, v squared minus 25. Because 2v minus 19, those don't have any common factors. So it will simply be a 2v minus 19, and that would be over v minus 5 and v plus 5. So that doesn't simplify any further. There's no common factors between the numerator and the denominator there. So that is the end of adding and subtracting with unlike denominators. So the name of the game in that case is when you have different denominators, you need to change them by multiplying by that convenient 1 to the same denominator. And we use our least common multiple of those denominators that's our new denominator that we're going to use. So in this case, that was a v plus 5 times that v minus 5. And then we simply use those missing factors to help us decide what that convenient one was going to be for each of those pieces. Okay, so that's the end of that. And let me know if you have any extra questions.